All right, we are back again with some units here. Question on base units, and okay, that is derived units and base units, right? The following equations may or may not be correct, right? Use base units to check if they represent the given relationships. The fundamental frequency f of an open pipe of length L when the speed of sound is v. All right, so when you are answering this type of a question, you need to show that the left hand side probably is equal to the right hand side, or the left hand side is not equal to the right hand side in terms of the base units for representing those given quantities. Okay, so you can probably write down the unit for the left hand side, which is the frequency, right? So on the left hand side we can see that we have frequency, and the units for frequency are, right, remember frequency is derived from 1 over t, right? This is not the unit, but the unit for t is second, so it's 1 over s, which translates to s to the power negative 1. So this is the unit on the left hand side. Then from the right hand side we have two quantities, the right hand side. Okay, there is v, right? The unit for v is meters per second. Okay, and then the unit for L, the unit for L is meter. So from those two we are actually dividing. All right, we are dividing v over L. V over L gives us what? M s to the negative 1 divided by m, and this will simplify to s to the power minus 1, because these two guys cancel out, right? And then we get s to the power. So now looking at those two, we can say that left hand side unit is equal to the right hand side unit. So what does this imply? It implies that this relationship is possible. Relationship is possible. It's possible that the frequency of that, the fundamental frequency of an open pipe may be given that equation, right? We don't consider 2 when we are just checking if an equation is homogeneous, right? But then when it comes to an equation being true or correct, then we need to consider those constants. But in this case, since the question had said we're using base units, so let's just stick to that. But otherwise the two may have an effect if probably the question had asked us to show or to prove whether the equation is true. Okay, so they say they may be true, may not be true. So the may part explains the idea that there might be some missing constants in that equation. But for this one, the fact that the SI unit on the left hand side is equal to the right hand side, so that means the relationship is very much possible. Now let's look at the second one. Okay, we're told the pressure P at a point in a fluid of a density rho moving with a speed v is given by that. So from definition we know pressure is equal to force over area, right? Let me use a capital letter there. It's force over area, right? And this translates to what in terms of units? Force is mass times acceleration, right? It's ma over capital A. So this translates to kg meters per second squared divided by meters squared. Using the laws of indices, okay, you can divide those two guys, m to the power 1. So we have kg m to the negative 1 there, and then s to the power minus 2. Right, so we have that on the left hand side. This is for the left hand side. Right, now let's look at the right hand side. On the right hand side, we can ignore the half part, but then we have rho, right? Rho is density, which is mass over volume. Mass is kg divided by m cubed for the meter, right? This translates to kg per meter cubed. And also we have v, and we know v is equal to meters per second. Now multiplying rho times V, this will give us what? Kg per meter cubed times meter per second, right? And this will simplify to what? If we simplify this, it's gonna give us kg. If you look, they have m to the power minus 3 and m to the power 1, so this is m to the power minus 2 and then s to the power minus 1. Now let's look very closely the unit for the left hand side and the unit for the right hand side. Right, on the left hand side with this one, and then on the right hand side with that one. So you can compare there. You can see we have a difference in terms of powers for m and s. So that means if the left hand side is not equal to the right hand side, right, this implies that the relationship is not possible. The relationship is not possible. So this equation is not true, in other words. Okay, now let's move on to the next one. The angle at which an aeroplane moving with a speed v should be banked to describe a path of radius of curvature r. Right, from the fundamentals we know that tan, the trig ratios, okay, let me call them trig ratios. Trig ratios are dimensionless. Okay, this guy is dimensionless. So if it's dimensionless, it means we have no units on the left hand side. So left hand side, no units. All right, now let's look at the right hand side. Right hand side, what do we have there? We have three quantities. Okay, there is v squared. V, remember, is meters per second, so this will be meters per second squared, and this simplifies to meter squared per second squared. Right, underneath we have r and g. Rg, right, r is given by meter, g, that's acceleration, right, because that's gravitational field strength, so that's meters per second squared. Simplifying this gives us meter squared, so this is a product, by the way, so you're multiplying those two, meter squared and then second squared. Now these two guys are dividing each other. You can see that when you divide m squared and s to the power, that they cancel out and they give us 1. So at the end of the day, we can say there are no units also on the right hand side. Right hand side, no units. So in other words, the left hand side is equal to the right hand side. So that means the relationship is possible. The relationship is possible. Okay, right, so this is how you deal with this type of questions. See you next time, guys. Thank you so much for watching.